Good morning, students. Good morning. Good morning, students.
Good morning, ma'am.
I thought, okay, very good. I will share the screen. Today, we will start the new chapter called as distribution theory. In syllabus, we are having three distributions. One is binomial distribution, another one is Poisson distribution, another one is normal distribution. Binomial and Poisson students are still getting. Okay, only 10 participants. It's already 10:30, right? Shall we wait for 2 minutes?
Yes, ma'am.
Today, because in BRM you are having this, maybe means formulas are not expected. Okay, interpretations are expected. Without knowing the formula, without knowing this, how you will be able to interpret? Today I will cover the basics, okay? Basics of binomial distribution, then we will go for problems. Okay, problems will come for 5 marks in the final exam. Okay, then. First, okay, means we will study random variables. Before going to probability distributions, you know that the probability is a numerical study between certainty and uncertainty is called as probability. Okay, everybody is aware. Okay, two types of distributions. One is discrete distribution, another one is continuous distribution. Okay, discrete. Already we discussed. Discrete means finitely countable, continuous means infinitely uncountable. That's why the integral limits for continuous distributions are in general minus infinity to plus infinity or 0 to infinity if you verify distributions. Discrete. Before going to discrete distributions, we should know what is a random variable. Okay? What is a random variable? Okay, random variable is nothing but a real number. It is always denoted by the capital letters, by the X, Y, Z. Always. Okay? A real number, capital X. In general, we represent with X. X represents the probability function in all distributions. Listen carefully because these are the basics. I am not saying anything else. A real number X associated with the outcomes of a random experiment. With the outcomes of a random experiment. It can take any one of the various possible values, each with a definite probability. For example, tossing of a coin. Okay, tossing of a coin. Probability of getting head, you are saying half. That means probability of getting head, you have to represent with a random variable. Probability of x is equal to half. Here, x represents head, for example. Okay, probability of y, you are representing it as half. Here, y is representing probability of getting a tail. Again, I am repeating. What is the random variable? Before going to discrete and continuous, we should know random variable concept before going to distributions. Okay, random variables is of two types. Again, discrete random variable and continuous random variable. What is a random variable? Variable is the value which varies. Already we discussed in earlier chapter. What is random variable? A real number. Real numbers are always represented by the capital letters X, Y, Z. A real number X associated with the outcome of a random experiment. You know what is a random experiment. Tossing of a coin is a random experiment. It is also known as trial. One of the other definition what we discussed. What is a random experiment? If an experiment is performed under similar homogeneity conditions, we may get the result any of the two possible outcomes. Outcome is unique or certain, that is called as deterministic phenomena. Correct ना? Probability में first introduction वही किया था हम लोग. Students remembered? पढ़ाई नहीं कर रहे क्या? I have shared that. Okay. A real number X associated with the outcome of a random experiment. You know the definition of a random experiment. It can take any one of the various possible values, each with a definite probability. For example, tossing of a coin, for example, probability of getting head is half. Here, instead of writing probability of head, you are representing with the random variable, that is X. Here, probability of getting tail is half. You are representing this with the random variable Y. Similarly, if you throw a die means what are the various possible outcomes? 1 to 6. 1 to 6. Again, random variables are bifurcated into two types, like distributions. How we have bifurcated? Random variables is bifurcated into two types, like in the graph. One is discrete random variable, the other one is continuous random variable. Whenever you deal with the discrete random variable, listen, what is the definition of discrete? Here, probability distributions as well as we are having. Discrete random variable. If the random variable is always represented by the letter X, I told. If the random variable X assumes only a finite number of values is called discrete random variable. Already we have discussed. For example, what is the example of discrete? Number of students in division B, number of defective mangoes in a basket, number of trees in Pimpri-Chinchwad area. Is it countable? Yes. Whatever the countable things are there, then that is discrete random variable. If it is continuous, a random variable X assumes countably infinite set of values. Countably infinite set of values is called continuous random variable. Okay, example of continuous random variable is age of MBA first year students. Okay, height, weight, all should come in decimals, correct? Then those are called as continuous random variables. Then, whenever you are dealing with, listen carefully, this is important. Again, I am repeating, a random variable is a real number. Real number, random variable is always represented by the letter X. A real number X associated with the outcomes of a random experiment is called a random variable. Random variables is bifurcated into two types. One is discrete random variable, another one is continuous random variable. Discrete random variable is nothing but finitely countable. This is finitely continuous random variable is finitely uncountable. That's why most of the time the integral limits are minus infinity to plus infinity, otherwise 0 to plus infinity. Okay, students, I wrote this just to go through. Here, instead of random variable, I wrote the probability distributions. Okay, listen, later we will study that. Here, whenever you are dealing with discrete random variable, probability mass function arises, PMF. Probability mass function. I will explain what is probability mass function. Whenever you are dealing with continuous random variables, we will get PDF, that is probability density function. If you are not getting, please in between you can interrupt me. Whenever you are dealing with discrete distributions, probability mass function, PMF, shortcut is PMF, probability mass function arises. What is this probability mass function? Probability distribution of a discrete random variable. What is this PMF? Probability distribution of a discrete random variable is probability mass function. Probability distribution of a continuous random variable is nothing but probability density function. Okay, how we will define PMF and PDF? Okay, a discrete random variable x which can take the possible values, for example x1, x2 and so on xn. Whenever you are representing the suffix n is here finitely countable. Again, whenever we are considering discrete random variable, probability mass function arises. What is probability mass function? A discrete random variable x which can take the possible values, because finitely countable we are saying the definition of discrete, which can take the possible values x1, x2 and so on. Here n is finite, which can take the value of a random variable x, which can take the value of a random variable x. We associate a number, then we will write the representation of probability mass function is probability of x is equal to small x. We will represent probability mass function in this. In binomial distribution also the definition lies same. Probability of x is equal to x. Here if you are taking I running from 1 to n, here x is equal to xi. This, listen students carefully. Notations are important in the three distributions. We are having three distributions. Yesterday I checked after Pratik told me no, whether be in PRM it is there or not. It is there. Yesterday I have checked again. Okay. Then random variables is bifurcated into two types, discrete and continuous. Whenever you are dealing with discrete random variable, probability mass function arises. Probability mass function is nothing but probability distribution of a discrete random variable. Here, okay, random variable x which can take all the possible values, that is x1 to xn, that means finitely countable, that is representing as I running from 1 to n. That's why the representation is probability of x is equal to xi is equal to pi. Remember in transportation problem, Cij into Xij, we used to write Pij, the corresponding probabilities. Here x is equal to xi, that we will represent it as Pi. That is first one. This should be strictly greater than or equal to 0. This is the first condition of a discrete random variable. What is the first condition? Probability of x is equal to xi. This is represented as Pi. This is strictly greater than or equal to 0. Again, this is called as a non-negativity condition. In LPP also we studied. After writing linear equations, we used to write an x comma y greater than or equal to 0. The second condition is, this is the first condition. The second condition is sum of all cumulative probabilities. Sum of all cumulative probabilities is equal to 1. This is the condition of probability mass function, discrete case. समझ रहे क्या थोड़ा बहुत students? Existing or not existing? Deepali, समझ में आ रहा है?
Yes, ma'am.
हाँ.
थोड़ा.
हाँ. You have to write today itself. Please make a note and then write. You should have it. Okay? You cannot say I don't have maths background. That's why these terms I don't know. No. Again, random variables is bifurcated into two types. One is discrete, another one is continuous. If it is discrete, probability distribution of a discrete distribution is called as probability mass function. The condition for probability mass function is whatever the random variable, capital X, is associated with nx, that is x1, x2 and so on xn. The first condition we have to write probability of x is equal to xi. The representation of this is pi should be strictly greater than or equal to 0. This is called as non-negativity condition. Similarly, the second condition here pi, that means I running from 1 to n, where n is finitely countable. Summation I running from 1 to n, pi is equal to 1. Till here clear? Then here, whenever you are dealing with continuous random variables, probability distribution of a continuous random variable is always denoted by probability density function, that is PDF. Okay, that is always represented by PDF. Okay, in some textbooks it is given as P of x, in some textbooks it is given as f of x. Better to represent instead of P of x. If you write P of x, confusion arises whether it is of discrete or continuous. That's why better to take f of x. F of x should be strictly greater than or equal to 0 here also. The condition is same if it is continuous. What I told, the other one what I told, it always lies between integral limits x. That means it is always lies between integral limits, that is x is lying between certain interval. That is, if you are taking a less than or equal to x less than or equal to b is equal to 1. P or f, your wish, whatever you want to take. Again, whenever you are dealing with infinite, uncountable values, uncountable number of values, probability distribution of uncountable number of values is called as probability density function. Okay, like discrete probability mass function, the corresponding properties are greater than or equal to 0. The random variable probability of x is equal to xi, I running from 1 to n finite values should be strictly greater than or equal to 0. The second one is all probabilities, summation of all probabilities should be equal to 1. Like that, if probability density function is having the following rules, here probability density function should be strictly greater than or equal to 0. Instead of summation, it is replaced with integration. In continuous case, integration a to b, here the integral limits, that means the continuous random variable lying between a to b, f of x dx is equal to 1. Don't get scared. Integration hai kya? No, we don't have any integration. Simple definition part only we are having. Integral a to b f of x dx is equal to 1. This is the introduction of random variables.
मैम साइड का बोर्ड में दिख रहा, राइट साइड.
Integral, write down integral. Yesterday they have changed the setup again because of meeting. Integral a to b f of x dx is equal to 1. And then I don't write f of x dx is equal to, just right hand side equate it to 1. Okay, I will write till here only. Okay. Then go through discrete probability distributions. Here also we discussed the same. Discrete probability distribution assumes a countable number of values, many possible outcomes. Here examples: number of complaints per day, number of TVs in a household, number of rings before the phone is answered. Okay, this is called as, if you are dealing with only two possible outcomes, gender, male or female, defective, yes or no. Okay, possible outcomes, two possible outcomes. This is called as which classification? आप लोग SIP में तो मेरे को questions भेज रहे हैं questionnaire में. If it consists of two possible outcomes, it is known as which classification? Dichotomous classification, correct? आप लोग marketing का students, finance है ना, B, division B. Okay. Continuous random variable examples: thickness of an item, time required to complete a task, temperature of a solution, height in inches. These are called as continuous random variables. Okay. Right now we will discuss with binomial theorem. This is important for research perspective as well as exam perspective. Okay. Here I told discrete distributions, n number of discrete distributions, binomial, Poisson, geometric, hypergeometric, negative binomial, n number of discrete distributions. But in our syllabus, we are having only two distributions, that is binomial and Poisson distribution. These two distributions comes under discrete distributions. Binomial distribution was discovered by James Bernoulli in the year 1713. He is a Swiss mathematician. Again, binomial distribution is also known as Bernoulli distribution because James Bernoulli has discovered this distribution. That's why sometimes binomial distribution is also known as Bernoulli distribution. This distribution was invented in the year 1713. He is a Swiss mathematician. Okay. If you want to follow binomial distributions, we have to assume some assumptions. We have to assume some assumptions. In BRM, you have studied hypothesis testing. How many types of hypothesis?
Two.
What are those?
Null and alternative.
Null hypothesis, alternative.
Null and alternative.
Null and alternative hypothesis. Is it a research hypothesis or is it a statistical hypothesis? Before null and alternative hypothesis, how many types of hypothesis? Very good, very good. Tell me the answers. Null and alternative, correct. Is it a statistical hypothesis, null and alternative, or is it a research hypothesis?
Statistical.
Justify. If it is statistical hypothesis, justify. Why you are saying this as a statistical hypothesis? Then if it is a statistical hypothesis, what is a research hypothesis? No idea? Research hypothesis, very good. This is given one is a null and alternative hypothesis or statistical hypothesis, because research hypothesis is the hypothesis, it is defined in simple English terms. Consumption of sugar, example, we will differentiate between a research hypothesis and statistical hypothesis. For example, if it is a research hypothesis, the sentence formation is like this. Okay, children consume more sugar. Okay, children consume more sugar. Simple English sentences. Then it is called as, if it is defined in simple English language, then it is called as a research hypothesis. Whenever we are seeing null and alternative hypothesis, it talks about population parameter. That's why it is a statistical hypothesis. Hypothesis is an assumption or assertion about population parameter in case of statistical hypothesis. In case of research hypothesis, it is purely qualitative. Okay. Again, coming back to this binomial distribution. Binomial distribution is having certain assumptions. Binomial distribution is having certain assumptions. Listen the assumptions carefully here. Random experiment is performed repeatedly, finite and fixed number of times. First assumption is random experiment is performed repeatedly, a finite and fixed number of outcomes. That means the number of trials, the first condition, number of trials is always represented by the letter small n. Number of trials is finite and fixed. That is the first condition when we will follow binomial distribution. These assumptions you have to remember, students. Okay. The outcome of the random experiment results is dichotomous classification. You have studied this dichotomous classification in 3rd chapter BRM. Dichotomous classification. The possible answers are yes, no, sometimes can't say. Correct? Manifold classification, dichotomous classification, bifold classification. Questionnaire में किया था ना, construction of a questionnaire. How many types of questions? 3rd chapter में questionnaire किया है ना BRM में सब लोग. Add नहीं है क्या कुछ भी? Refreshed? Huh? The second assumption, the outcome of the random experiment results dichotomous classification of events. Third one, the third assumption is all trials, whatever the trials you will conduct, are independent. This is the third assumption. All trials are independent. The fourth one is the probability of happening of an event. The probability of happening of an event is always represented by success. The probability of happening of an event is always represented by success. Success in binomial distribution is denoted by P. Okay? The other vice versa. The probability of not happening of an event is known as failure. Failure is always represented by the letter Q. These are the four assumptions we have to remember in case of binomial distribution. Again, I am repeating. Binomial distribution is also known as Bernoulli distribution. A Swiss mathematician named James Bernoulli was discovered this distribution in the year 1713. The assumptions underlying the binomial distribution are as follows. The first one is the number of trials, that is n. The number of trials is finite and a fixed number. Second, the outcome of a random experiment results is dichotomous classification, that is SR1. Third, all the trials are independent. You know independent event definition. The probability of happening of first event does not depend upon the happening of the second event. Throwing up a die, first time I got the outcome as 6. Again I thrown a die, I got the outcome as 6. That means the happening of first occurrence of an event does not depend on the occurrence of the second event. Then fourth one, probability of success. That means what? Probability of happening of an event is known as success. Probability of does not happen that event is known as failure. Success is always denoted by the letter P. Failure is always denoted by the letter Q. The linear equation here is P plus Q is equal to 1, where Q is equal to 1 minus P. These are the assumptions. Next. It has to follow, these are the assumptions, okay? It has to follow certain conditions. Binomial distribution has to follow certain conditions. What are those conditions? We will see right now. Same, first, whatever the assumption we have assumed that is there, that is the number of trials in assumptions what we wrote, number of trials is finite and fixed. Here n, the number of trials is finite. Second, each trial, here, illustration of this only, the conditions. Each trial results two mutually exclusive and exhaustive events. You know the definition of mutually exclusive and exhaustive events. What is mutually exclusive events? Two or more events are said to be mutually exclusive. If the happening of an event excludes the happening of other event is called mutually exclusive. What is exhaustive? The totality of all possible outcomes in a trial is called exhaustive. Correct? Here. Second condition is each trial results in two mutually exclusive and exhaustive outcomes termed as success and failure. Third one is trials are independent. Fourth one, probability of the success is constant in each trial. We consider that word. Probability of the success in each trial is constant. Then failure is denoted by the letter Q, success is denoted by the letter P. Finally, probability of success plus probability of failure is equal to 1. P plus Q is equal to 1. These are the conditions we have to remember for binomial distribution. Then, how binomial distribution probability mass function arises, we will write down this. Okay. Everybody remembered this, I hope, in 10th standard binomial theorem we learned a plus b whole to the power of n. What we used to write? NC0, if you remember, a to the power of n into b to the power of 0. A power decreases, b power increases, correct? NC1, a to the power of n minus 1, b to the power of 1, where In 10th standard, we used to study A and B are constants plus NC2, A to the power of n minus 2, B to the power of 2, plus and so on. If it is true for, by using mathematical induction, it is true for R events, A to the power of n minus R into B to the power of R plus and so on. Correct? Here substitute A and B value as 1 and 1, then it will become 1 plus 1 whole to the power of n, that is 2 to the power of n. You are dealing with two events, that's why it is called as binomial expression or binomial. Correct? Now in 10th standard you have studied the same concept. Binomial. A plus B whole to the power of n is equal to NC0. That means, what does it mean? NC0, what does it mean? N items are available. You don't want to choose any item. What is the meaning of NCR? Anybody? Permutations and combinations add है किसी को? Permutations and combinations आता है नहीं आता? If you say no, then I will explain. Permutations and combinations, what is the meaning of a permutation and what is the meaning of a combination?
No, ma'am.
No idea, ma'am.
Okay, here listen, probability concept. There are two types of objects. One is distinguishable object. Another one is indistinguishable. Okay, I am representing this as how many types of objects? Two objects. Distinguishable and indistinguishable objects. Okay. Here, what are the possible combinations? Listen carefully. You can compare distinguishable object with a distinguishable object. You can compare distinguishable object with indistinguishable object. This combination is over. DD, DI. Then, if you want to compare indistinguishable object with the distinguishable object, this is one combination. You want to compare indistinguishable object with indistinguishable object, then these are the four combinations we are having. What does it mean? Okay, these are the objects I told you. Okay, here, for example, mathematics or statistics word. Mathematics. Okay, here, listen. If I ask, arrange the same letters in a proper order, arrange the same letters in ascending or descending order. That means we will use the combination called as permutation. Permutation word appears when you are arranging the objects. Arranging the objects. For example, if you want to arrange the objects ascending to descending order, for example, if you want to start with how many A's will be there in mathematics word, for example, how many A's you are arranging, first it will come A, next order is C. This is called as permutation. That means whatever the word is given, you are arranging the letters. This is called as permutation. For example, how NPR formula comes. This a formula नहीं है तो हम लोग कुछ नहीं कर सकते. Binomial Poisson, 0 marks. Listen carefully. For example, n objects are there. How many objects are there? N objects are there. Okay, n objects are there. Okay, I want to arrange among those. I want to arrange R objects. Total number of objects are n. I have to arrange only R objects, then the formula is NPR. Whatever the objects, maybe distinguishable to indistinguishable, I to D or I to I. Again, n objects are available. Among those n objects, you have to arrange R objects, then the formula is NPR. Then, what is the formula? How we will write? ये सब 10th standard में भी है.
n factorial n minus r factorial.
Very good. N factorial upon n minus r factorial. For example, the other case, n objects are there. Again, r objects I am taking. Earlier case, what I am saying, among n objects, I have to arrange r objects. In this case, n objects are there. I have to select those. Arranging and selection, Jameen Asman ka farak hai. N objects are there. Then I have to choose. I have to select r objects. That is called NCR. That is called NCR. The formula, that means among n objects, the researcher is choosing r objects. In this case, among n objects, the researcher is arranging r objects. Then NCR, the formula is factorial upon
n factorial r factorial n minus r factorial.
factorial. Very good. This way we should know, because to solve binomial, if you didn't remember, please write down this. 10th standard over, and in PRM also this you should know. If you want to make a note, make a note. Okay. Then, okay, how we will write the probability function of a binomial distribution? Listen carefully. I have performed n trials. I have performed how many trials? N trials. That is finitely countable or infinitely countable. Later we will see. Tossing of a coin, for example. Tossing of a coin, I have performed n times. What I have performed? Tossing of a coin. For example, my assumption is, as a researcher, my assumption is, if head comes, I will consider it as a success. If head comes, I will consider it as a success. If tail comes, I will consider it as a failure. I will consider it as a failure. For example, I toss the coin how many times? N times. That means your S. Okay, first time I got S. Second time I got F. S, S. Okay, F, F, like this. How many times I have performed? N times. How many times I have performed? N times. Okay. Among n times, okay, here whenever S appears, as a researcher, I am assuming after performing a random experiment n times, wherever success comes, then I assume that X times success comes. X times success comes. That means how many failures? N minus X failures. Correct now? Again. Here, I have performed a random experiment, that is tossing of a coin. If head comes, then I have considered as a success. If tail comes, I have considered it as a failure. Like that, n times I have performed. Among those n times, my assumption is X times which appeared, success has appeared. That means X times success has appeared. That means failure how many times comes? N minus X times failure comes. Then, if success, according to the conditions of binomial distribution, success is always denoted by P, failure is always denoted by the letter Q. How we will define binomial distribution right now? How many trials I am performing n times? Among those, as a researcher, I have choose X times so success appears. Choosing means combination, that is NCX times.
X.
NCX times, correct. Then success comes, how many success is always denoted by which letter? P. How many successes? X successes, that is P to the power of X. Then failure is denoted by what? Q. How many failures? N minus X. This is the story behind binomial distribution. This is the story behind binomial distribution. Then binomial distribution is a discrete distribution. That's why probability mass function occurs. What is probability mass function? We described X is equal to Xi earlier introductory session. That's why probability of X. Here we will write probability of x is equal to x. This is binomial distribution, where x running from 0